Today's lesson is on domain and range of a function. First, we'll look at our key idea for functions. A function is a relationship that pairs each input with exactly one output. The domain is the set of all possible input values, and the range is the set of all possible output values. For our first example, we're finding domain and range from a graph. Find the domain and range of the function represented by the graph. First, we'll write the ordered pairs, and then we'll identify the inputs and outputs. So our ordered pairs are -3, -2, -1, 0, 1, 2, and 3, 4. Our inputs would be the x values, and our outputs would be the y values. Our x values would be our domain, and our y values are the range. So the domain is -3, -1, 1, and 3. And the range is -2, 0, 2, and 4. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. Find the domain and range of the function represented by the graph. So the first thing we'll do for number 1 is we'll write out our ordered pairs. So we'll start here on the left and we'll move across the graph. So we have -3, -3 for our first ordered pair. Our next one will be -1, -3. And then we have 1, -3. And we have 3, -3. The domain would be our x values. So we have -3, -1, 1, and 3. So -3, -1, 1, and 3. And the range is our y value. So -3, -3, -3, and -3. So our range for all of them would just be -3. Now for number 2, we're going to write down our ordered pairs. We'll start here on the left side of the graph and we'll work our way around. So our first ordered pair is -2, 4. And then we have -1, 2. We have 0, 0. We have 1, 2. And we have 2, 4. Now for the domain, we're going to look at our x values. So -2, -1, 0, 1, and 2. So -2, -1, 0, 1, and 2. And then our range, we're going to look at the y values. So we have 4, 2, 0, 2, and 4. So we have 0, 2, and 4. Now we're going to look at a vocabulary word. An equation is in function form if it is solved for y. So for the first one, x plus y equals 1 is not in function form because it's not solved for y. The second one, y equals -x plus 1, is in function form because it is solved for y. Now for example 2, we're finding the range of a function. The domain of a function represented by 2x plus y equals 8 is -2, 0, 2, 4, and 6. What is the range of the function represented by the table? So the first thing we're going to do is write the function in function form. So we're going to solve for y. In order to solve for y, we're going to subtract 2x from both sides. So we're going to have that 2x plus y equals 8 would then be y equals -2x plus 8. We're going to use this form to make an input and output table. When we do our input and output table, we'll then put -2 into our equation. So we'll substitute in for x and we'll solve to get y. So we have -2 times -2, and then we'll add 8. Negative 2 times negative 2 is 4, plus 8 is 12. Now for 0, negative 2 times 0 is 0, plus 8 is 8. Now we can put in 2, so negative 2 times 2 is negative 4, plus 8 is positive 4. And if x equals 4, we have negative 2 times 4, which is negative 8, plus 8 is 0. And for 6, we have negative 2 times 6 is negative 12, plus 8 is negative 4. The output values will be our range. So the range is 12, 8, 4, 0, and negative 4. Now we have an additional example. You can pause the video and try it on your own, or you may follow along. Copy and complete the input-output table for the function. Then find the domain and range of the function represented by the table. For number 3, we have y equals 2x minus 3. We're going to put in our x values and solve for y. So for negative 1, we would put that in. We have 2 times negative 1 is negative 2. Minus 3 would be negative 5. And then we're going to solve if we put in 0 for x. So 2 times 0 is 0. Minus 3 is negative 3. Now we'll go ahead and solve if x equals 1. So 2 times 1 is 2. Minus 3 is negative 1. And we'll solve if x equals 2. So 2 times 2 is 4. Minus 3 is 1. Now our domain is the x values. So we have negative 1, 0, 1, and 2. And the range would be our y values. So negative 5, negative 3, negative 1, and 1. Now let's look at number 4. We have x plus y equals negative 3. This is not in function form, so I'm going to solve for y so that I can use that to help me then fill out my table. I'm going to put it in function form. So I need y equals, so I need to subtract x from both sides, and I will get that y equals negative x minus 3. So now I'm going to use this equation to find my y values. So if x equals 0, I have negative 0, or just 0, minus 3, and that's negative 3. If x equals 1, I have negative 1 minus 3, which is negative 4. If x equals 2, I'll now have negative 2 minus 3, which is negative 5. And if x equals 3, I'll have negative 3 minus 3, which is negative 6. Now I'm going to use my table to write down my domain and range. My domain would be the x values. So I have 0, 1, 2, and 3. And the range would be my y values. So negative 3, negative 4, negative 5, and negative 6.